The topic I'm going to explain today is fractional distillation. What fractional distillation is, we'll see its definition, the apparatus that we can use to carry out fractional distillation, the principle on which it works, and the uses of fractional distillation, and how can we separate different components of petroleum and the uses of these different fractions. So let's start it from the definition, that how can we define fractional distillation, what it is actually, and on which principle it works and how it works. So fractional distillation, our main focus will be on the fractional distillation of petroleum by using the fractionating column. It is a physical technique. Why we call it a physical technique? Because it is based on the physical property, boiling point of the components of a mixture. So fractionating column is basically a process in which we are heating a substance that we need to separate. We know that the solution are made up of different components like solute, solvents are mixed together. But if certain liquids are mixed together and forming a solution, and then there is a physical method that we can use to separate these different components. How we can separate them? That is completely done by boiling the mixture, and the components are separated on the basis of their difference in the boiling point. And these products of the fractional distillation are further used, as we'll talk about the fractional distillation of petroleum and where and how can we use its different components. So if you want to write down the definition of fractional distillation, that is a breaking down of the mixture to its component parts, and this is done, and if the question comes in the past papers, as it usually comes, that what is the basic principle on which fractional distillation works. So that is the boiling point or the physical property. If they ask you on which it is based or works, then the principle or the physical property is the boiling point. It is done by boiling the mixture and then separating the products on the basis of their different boiling point. How this can be done, we are going to talk about it further, along with the apparatus that can be used and the name of the apparatus. As you can see this diagram, that we are using a fractionating column, a round bottom flask, a source of heat, a condenser, and a collecting jar. If we are having a mixture of ethanol and water and we started heating it, what will happen? That mixture will start boiling off, and the water and the ethanol vapors will start moving from here, round bottom flask, to the fractionating column. Okay, let me first explain you the function of these three components. This round bottom flask is containing the liquid to be distilled. It's a container, acting as a container. This is a fractionating column, and it is attached to this round bottom flask at the bottom and the thermometer at the top. And the bulb of the thermometer should be kept very close to the mouth of the condenser, this opening where this condenser is attached. So basically this fractionating column is attached to three components of the apparatus: the round bottom flask, the thermometer, and the condenser. This round bottom flask is acting as a container to keep the liquid that we need to distill. Like I've just given the example of ethanol and water, and we are going to do the distillation of this mixture and see how it will work. The fractionating column consisting of the glass beads, and these glass beads provide the large surface area for vapors to condense on. How and why this is required, I'm going to explain you further in the lecture. So thermometer is used to record the reading, and the bulb of this thermometer should be kept very close to the mouth of the condenser. So according to the past paper questions, what points to ponder on is where should be the position of the thermometer. The bulb should be very close to the mouth of the condenser, and they ask you usually that what is the purpose of glass beads. So glass beads are actually placed in the fractionating column to provide a large surface area for vapors to condense on. And this condenser is attached to this fractionating column to condense the vapors which are coming from here. So, and the direction of the water is from bottom to the top. So it is against gravity, and usually they ask you why this position is favored or what is the direction of water. Then the answer you are going to write is that against the gravity, to keep this condenser filled all the time, and the direction of the water is kept in the reverse against gravity, like water in, and that is water out, so that the condenser is filled with the cold water all the time. Why this is required? Because once the vapors will come from here, they should get this cold environment to get condensed back and then separated. So how it works? If we are having a mixture of ethanol and water here, so what happens? First of all, as the heat is provided, the ethanol vapors and the water vapors will rise up the column as a solution is heated, and then they go here. Both the water and the ethanol vapors go here. As water vapors are having the higher boiling point than ethanol, so these glass beads are providing hindrance. The temperature in this fractionating column is in a way that supports only the vapors of ethanol to pass through it, and the water vapors will condense back and drop back here in the round bottom flask. And so ethanol with the lower boiling point will reach the top of the fractionating column, as you see my cursor here, and then goes to the condenser, condense and separate it. And the water, because it boils at 100, as we all know, and ethanol boils at 78, so there's a huge difference in the boiling point of both the liquids. So ethanol will boil off first, but as we are heating the mixture, so there is a chance that water molecule can also boil off along with the ethanol. But these glass beads are providing the hindrance and surface area for the water to condense back. So water will drop back and ethanol will pass through the condenser and separate it. So this was the function, apparatus, process of fractionating column. These were the components, 4 components: the thermometer, the fractionating column, round bottom flask, source of heat, and the fraction and the condenser, and the direction of water we spoke about, and the collecting jar in which these components are separated. So another point to mention here is the temperature will stay constant when there is a state change. If you have gone through my previous videos where I have explained the heating and the cooling curve, then there you must have known that when there is a state change, the temperature does not rise. What is the reason? Because all the heat which we are providing is used to break the bonding at that point when there is a state change, as the boiling is happening here. So that energy which you are providing at the boiling point will be used to break the bonding between the liquid molecules and to convert it into the vapors or gas, so the temperature will not rise. So when the temperature will show the first steady reading 78, that means that is the boiling point of ethanol, where all the ethanol will be separated and boil off. And then when all the ethanol will be done with its separation, then the temperature on the thermometer will start rising, and the second steady reading you will see at 100 degrees, where water will start boiling. So these were some explanations of the past paper questions where they can ask you, I'm repeating it for you, what is the function of glass beads, where should be the bulb of the thermometer, and where you see the steady readings of the first and second, why the temperature does not rise, what is the function of condenser, what is the direction of water, why the direction of water is this way, and all that. Now this was the process of fractional distillation. Now let's go to the application. Application, as I have told you in the objectives that we are going to discuss, that how the different fractions of petroleum are separated into its component and why we need to do that. The purpose to do is that petroleum is a mixture of many components and all the components have their own uses. These components can be separated by using the process fractional distillation, because all the components have the different boiling points and very important uses as well. So how it works? Here is a boiler that is a container or a place where the petroleum is heated. When it is heated, it will start converting into vapors. These vapors of petroleum are directed to this fractionating or distillation column. In this distillation column, the temperature at the top is less as compared to that at the bottom. So those vapors with the low boiling point, of course, they boil off first and go to the distillation column and go at the top, and then they are attached to the condenser and then they separate. So as you see that the first component that separates are at 20 degrees centigrade, and then first the gases will go and then the liquid petrol, and then the temperature reaches 30 degrees, and then as you see my cursor rolling down, the temperature increases and the different fractions are separated. And this is how fractional distillation is very useful in separating the different components of petroleum. So why they are having the different boiling points? The reason is, I'm going to explain it further, so keep listening. If you are being asked that how the process of fractional distillation works to separate different fractions of petroleum, then you can write this down. I'm reading it for you. Petroleum or the crude oil is heated until it boils, and then the hydrocarbon gases are entered into the bottom of the fractionating column. As these gases have the lower, of course, boiling point, so they goes up the column with the temperature decreases, and these gases are condensed back to liquid and the fractions are separated on the side of the column. The different fractions have different uses. So going back, and this is how all the fractions are going to separate, the same process. So how the question is appearing we are expecting the question, past paper questions to ask us. So they are usually asking the process, how it works, and in that process you need to include certain things. Let's see. Yes, what points you need to include in your answer while writing the separation of the different components of petroleum. First of all, you will write the separation of the different components of petroleum is done by the process called fractional distillation, which works on the difference in the boiling point of all the components. Right, these 2 points, like the name of the process and on which it works. Number 3, you will write that the fractions which are having the lower number of carbon or lower MR, so the smaller molecules or the lighter fraction. So mostly in the marking scheme, they are using the word lighter fractions or heavy fractions to represent the less number of carbon atom and the more number of carbon atom respectively. So you are going to write the lighter fractions have lower boiling point, so they boil off first, goes to the top of the fractionating column here, and then condense and separate it. And the same you're going to repeat for the heavy fractions. The heavy fraction stays at the bottom, heavy fractions at the higher boiling point. So don't forget to mention the lighter fraction at the lower boiling point and the heavy fraction at the higher boiling point. So they are collected at the bottom of the fractionating column or the distillation column. They are condensed and converted back to the liquid and used. So basically, they are going to ask you how fractional distillation works. So this is what you are going to write, whatever I have explained here. And if they're asking you how the different fractions of petroleum are separated, so this is what you are going to include. And these points you are going to include. First, you will explain, you will tell the name of the process, then how it works, the smaller fractions, or the hydrocarbon molecule rises up the column before condensing, so the fractionating column operates continually. The temperature shows here the shown are approximate, so that can even change. So that shows the less than 40. So as you see here, less than 40 means there can be 20 and then 30 and then so on, it increases. So the first point you're going to try write is the name of the process, fractional distillation. Then you are going to write it works on the difference in the boiling point of the different fractions. Third point, you are going to write the smaller fractions at the smaller the lighter fraction. The lower boiling point goes to the top of the fractionating column, condensed and separated, and the heavy fractions are having the higher boiling point, so they are condensed at the bottom of the distillation column and condensed and separated. So let's talk about the most important part, that the name of the different fractions. I'll go back and then you can note down from the slide the names and the uses, because in paper 1 all the questions which they are going to include from the petroleum are the uses matched with their names, or they may give you the name and ask the use, or there is a table form where they can give write the fractions name on one side and the uses, and they ask you choose the correct combination. So this is the type of the question they are going to ask. So let's go back and see there. Okay, the names are here. Fuel, so gases that boils first, petroleum gas. So what is the use? That is a feedstock for petrochemicals, like whatever the other chemicals we are producing in the industry that can use these petroleum gases. So this is acting as a fuel for running the factories to form the like other products like acids or whatever the use is, it is as a fuel. So petroleum gas can be used as a fuel and as a feedstock for petrochemicals. So you must have heard that there are many products made up of petroleum, like a petroleum jelly, Vaseline. So that is made up of those are actually there can be the example of petrochemicals. The second one is naphtha, gasoline, where it is used as a fuel. Gasoline is used as a fuel and naphtha is used as a feedstock. Kerosene is used as a jet fuel or domestic heating. Diesel can be used and fuel for trucks or the agricultural machinery, like the heavy type of vehicles can be run, or the machinery can be run by using diesel. Fuel oil is the oil for fuel for the ships and industries, and then the residue is used for making the roads, which is we usually call it a bitumen as well. But in your resource books you will find more uses. If you want to note down from here you can, otherwise in your reference books or the books you are using as your resource, that includes everything. So there is no need to write this, but if you want to write you can. I'm going to repeat it. Petroleum gases can be used as a fuel for cooking and heating. Then comes the gasoline. Yeah, that is used for fuel for motor cars. Then naphtha is very important. It is used as a feedstock for making petrochemicals such as plastic and detergents. Then kerosene oil, which is also called as paraffin, that is fuel for aircraft engine cooking and using oil stoves and cooking using oil stoves and heating. Then diesel oil used for diesel engines, of course, as I told you, the bigger vehicles, buses, lorries, trains. Then lubricating oil, which is also called as fuel oil, that is used for lubricating machinery, fuel for the ship and industries, and can be used for making waxes and polishes. So waxes and polishes, the better names you can use, because most of the time they're using these words, waxes and polishes, in their questions and paper 1, and asking and expecting the answer to be written as waxes and polishes in paper 2, as you observe that in the marking scheme. So residue is used for making, which is also called as bitumen, that is used for making roads and road surfaces and roofing. So let's move further. We are going to get a better idea. Gasoline, which is petrol, used for vehicles, motor cars, fuel for motor cars. So I have just attached these slides so that by looking at the picture that image stays in your mind. It's easy for you to remember. So fuel for motor cars, and then kerosene oil is used for aircraft engine cooking using oil stoves and heating. So I have added lamps here, the air jet, or this is also called as a jet fuel. Then comes the diesel oil. Diesel oil is used for the heavy vehicles, fuel for the heavy vehicles. And here, lubricating oil reduce the friction, like a lubricating oil, reduce the friction between the different parts of the machinery. And residue is used for building roads. So this was for all for today. Let's review this. What we have discussed today is, and if any point is left. Okay, first of all, we discussed what fraction distillation is. Like, it's a physical technique used to separate different components of a solution. So our main focus was on petroleum. Then we discussed the definition and the physical property on which it is based. Then the process, operators, functioning of operators, how to assemble the operators, what precautions we should take. Then the fractional, how to separate different fractions of petroleum. Then the process and the answers, past paper question and the answers, how the best answer we can write through as per the marking scheme ask us. And then the different names of the different fractions along with their boiling points and their uses. And then I have included these slides just for your remembrance that where we can use this. So this was all about. I hope this is going to help you solving the past paper questions. If you have any other topic which you want me to record and give a explanation of, please write in the comment section. I will try to get back to you soon. Thank you so much. Take care.